Hello guys, today we are going to be looking at VT graphs. Right, so here we notice that in a velocity time graph, acceleration is given by change in velocity over change in time. V2 minus V1 means change in velocity, T2 minus T1 change in time. Right, let us suppose that we want to find the acceleration for the object shown here in this VT graph. Old velocity is 14, old time is 0, new velocity is 0, and old velocity, rather new time is 7, and old time is 0. Right, if we find acceleration using that formula, it gives us -2. I want you to notice something, is that the line slants downwards. The line slants downwards from left to right, and our acceleration is negative. So whenever we have a downward slanting line, acceleration is negative. What about when we have an upward slanting line, like in this case? Right, in this case our acceleration is going to be positive. Change in velocity is 14, change in time is 2, and our acceleration is positive. But take it as a rule of thumb that whenever we have an upward slanting line, this line here, it slants up. So whenever this line slants up, our acceleration is positive. What about the case when we have a horizontal line, a line that neither slants upwards or downwards, a line that is just horizontal? It means acceleration is 0. In other words, our velocity is constant, it doesn't change. Right, so if we are using velocity time graphs, I want you to also note that the distance traveled by the object is the area under the graph in the time frame under consideration. Let us suppose we want to find the distance traveled from t0 to t is 2 for the object shown in this VT graph. The distance is going to be the area, the shaded area of that triangle there. So we calculate that shaded area. It's a triangle, so the area is given by the formula half base times height. Right, in this case, we have a base from 0 to 2, which means a base of 2, and a height from 0 to 5, which means a height of 5. So half base times height, right, that's our height there. Half base times height is going to give us what? 5. 5 meters is our distance. Since meters are the SI unit of distance or displacement, as it is in this case. Let us suppose we want to find the distance traveled or displacement of the object from t is 6 to t is 11. If our object is traveling in a straight line, distance is the same as displacement. But if our object is not traveling in a straight line, then there is a difference between distance traveled and displacement. We will talk about that in another video. Right, but in this case, we want to calculate the distance traveled from t is 6 to t is 11. It's again the area of a triangle. Half base times height gives us 25 meters, just as calculated previously there. Right, let's look at this example. Let's see if we can work out what is required here. Calculate the train's acceleration during the first 5 seconds. We're told that there's a train that starts from rest, accelerates to a certain velocity in a certain time frame. So let's see if we can calculate the train's acceleration during the first 5 seconds. And we're told that it accelerates to 20 meters per second from 0 in the first 5 seconds. So that's the VT graph, and acceleration is change in velocity over change in time. Right, so calculating change in velocity, it's from 0 to 20, and change in time, it's from 0 to 5. So change in velocity is 20, change in time is 5. And we divide to get 4. The units for acceleration are meters per second squared, like that. The next question, asks us to find the distance traveled from when t is 6 to when t is 10 seconds. So, like we said earlier, we calculate distance traveled by equating it to the area under graph. Distance traveled is equal to area under graph. And in this case, we don't have a triangle, we have a rectangle. So the area of this rectangle is given by length times width. Right, that triangle shaded there. The area is given by length times width. And our length is the longest side, which is 20. From 0 to 20, that's our length. Our width is the shortest side, the shorter side, which is from 6 to 10, which is 4 units. So 20 times 4 gives us 80. 80 meters, that's the distance traveled. Right, let's find the acceleration. Let's find rather the value of v. To find the value of v, we have to remember that whenever we have a downward slanting line, our acceleration is negative, and the acceleration is the same from when t is 15 to when t is 23 seconds. So we just find that value of acceleration and try to work it out, including v in the equation. So our acceleration is change in velocity over change in time. Change in velocity is 20, change in time is 8.